Alright, in this video we're going to see how an image forms from an object sitting in front of a curved mirror. We're going to begin with an object. We're using a candle that is sitting in front of a concave mirror. And for each of these we're going to draw 3 rays, and we'll find where those rays converge to form an image. So to begin with, I'm going to use a ruler and I'm going to draw a straight line to the mirror that is parallel to the principal axis. This is our principal axis. So ray 1 comes in parallel to the principal axis, and when it hits the mirror, any light ray coming in parallel will pass through the focal point, and I'm going to call that ray 1. Ray 2 is kind of the opposite. It comes in through the focal point from the top of our object, and then it will come out bouncing off the mirror, coming out parallel to the principal axis. Now already I have a hunch that this is where my image is going to form, but just to be sure I'll draw a third ray. Ray 3 passes from the object through the center of curvature and back out, and I see that these 3 rays converge at a single point. That point came from the tip of my object, and it makes the tip of the image. So once again, object, image. The distance from the object to the mirror, DO, is this. The distance from the image to the mirror is this. And so I see an image here. I'm going to describe this image in a couple of ways. The image is a real image. Different kinds of images can form in mirrors like this. You can get real images which happen on the side of the mirror that light is passing by. You could take a real piece of paper, put it here, and you would see a real image. If we see a mirror form behind the mirror, this would be the mirror the image that you see when you look at yourself in a flat mirror. You're looking at somebody behind the mirror. That's a virtual image. Well, the one we've made here is a real image. This image is inverted, and it is smaller. Okay? Well, there's a number of other diagrams here. I'm going to skip ahead, drawing the same 3 rays we would find in this picture, that they would converge underneath the CC. Drawing the same 3 rays in this picture, they will converge beyond the CC. And I'm just going to take a picture of this when I'm done drawing them, and you can check to see if your solutions match that. So let's take a look at some tougher scenarios. What if my object is actually at the focal point? Well, ray 1, remember, comes in parallel and comes out through the focal point. Ray 2 goes through the focal point, and that doesn't make any sense because it's not going to hit the mirror. But ray 3 passes from the object through the center of curvature and back, and now I can see I'm never going to get an intersection of these 2 rays. That these 2 rays are parallel. When the object is at the focal point, there will be no image formed. And that makes sense. The focal point is the place where parallel rays of light come together and converge at that point. So if the source of light is at that point, light rays will emerge parallel and there will be no image. However, what if the object, instead of at the focal point, is now closer than the focal point? My first ray comes in parallel and comes back through the focal point. My second ray comes toward the focal point, but I'm not going to hit the mirror that way. So I'm going to go backwards, hit the mirror, and now bounce off the mirror parallel Remember, from the focal point hitting the mirror, it will come out parallel. And my third ray would go toward and back from the CC, and that's just not forming anything that is going to collide with those other rays. There's ray 3. So I'm not going to see any collision point here. However, if I allow my rays to be extended into the virtual world behind the mirror, I see that this red ray, this blue ray, and this green ray do indeed converge, and they form a new kind of image. This is the image you see when you hold a concave mirror very close to your face. You see a huge picture of your face behind the mirror. This is a new type of image. It's not real, it's virtual. It is not inverted, it is erect, meaning right side up. And it is not smaller as the previous ones were, it is larger or bigger. Okay. Finally, we've seen there's a variety of different images we can form with concave mirrors. What if our mirror is convex? In other words, the reflective side of it comes out at you. Now if our object, represented by this candle, is going to form an image, let's see what happens. Same 3 rays. One comes in parallel, but now notice for a convex mirror, the focal length is negative. It's behind the mirror, this focal point. So light will bounce off the mirror like this. The second ray comes in towards the focal point, but after hitting the mirror, it comes out parallel. Once again, I don't think we're going to get a converging point here, but just to draw the third one in, towards the CC and right on through. Alright, no convergence point in the real world, but in the virtual world, if I continue this ray backward and I continue this ray backward, all 3 of them come together behind the mirror and make a very small virtual image. This is the image you see when you look in a convex mirror. When you look at yourself in a convex mirror, you're always right side up, you're always virtual, or your image is virtual, and it always is smaller. So we have a virtual, erect, smaller image. That's how we would describe this one. So, a variety of images. We've found these images using 3 rays. So we know that we can, in a lab, find where an image would form. We see that we can find where images form with ray tracing. This can also be found in your textbook. And we see that we can find where the images form with algebraic expressions.